Okay, looking at 1A.3, I can determine if two triangles are similar by identifying the transformations from one to the other. So, similar figures are two figures whose angles are congruent, so their angles are the same, and sides are proportional. So remember, dilations, we talk about that, keep your sides proportional, okay? So two figures are said to be similar if one can be obtained from the other by a sequence of translations, reflections, rotations, and dilations. So if you can show me a set of transformations that moves one shape to the other shape, then you can say those triangles or whatever shapes are similar. So, are the triangles in the diagram similar? Provide math or an explanation to back up your answer. Okay, so looking at this first example, it does not matter which triangle you start with. Okay, I'm not going from one to the other. I just need one to match the other. So I'm going to start with ABC, just because it comes first in the alphabet. So in order to do this, the first thing I'm going to do is just write down my starting points. So A is at 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 210. B is at 2, -1, 2, 3, 4, 5, 6. And C is at -1, 2, 3, 4, 5, 6. -10, and then it's also down -6. Okay, so that's where I'm starting. The first thing I'm going to do is, I'm always going to start with a dilation. If I can see it change size, because just by changing the size, you're going to change the position, and all the other ones change position. So I don't want to like try and match it up first and then change the position on myself again so that I have to move it again. I'd rather just dilate it first and then move it once. Okay? So I want to know how to get from one to the other. So I do need to figure out my scale factor. Since I chose to start with ABC, that is my pre-image, and this one's my image. So just like before, I don't know where my pen went. K equals I over P. So 1, 2, 3, 4, 5, I'm going to use the bottom of it, and that's 6 units long. The bottom of this triangle is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units long. 6 divided by 12 is 1/2. So I'm going to start by multiplying my points by 1/2. That gets me my first new triangle. 2 times 1/2 is 1. 10 times 1/2 is 5. 2 times 1/2 is 1. -6 times 1/2 is -3. -10 times 1/2 is -5. -6 times 1/2 is -3. Alright, now I'm going to graph these new points to help me see what I need to do next. Okay, so I have 1, 5, 1, -3, and -5, -3. Okay, so we're getting closer. These do look like they're going to be the same, but I still have to prove it. So to me, it looks like it's just flipping, right? So I need to figure out where my reflection is. So I'm going to match up my points, right? That's the middle. These ones, that's the middle. These ones, that's the middle, right? So you should kind of be able to see that this is reflecting over that y-axis. Okay, I know with those triangles on top of each other, it makes it a little more difficult to see. But it is just flipping there. So now I'm going to do the same thing. And I'm just going to do double prime. Again, remember, flipping over horizontally, we're going to flip our x. Our x is what changes sign. So it becomes -1, 5. B double prime becomes -1, -3. And C double prime becomes 5, -3. Okay, again, you can kind of do it graphically and know, okay, yep, this is 1 away and that's 1 away. This is 1 away and that's 1 away. And these are 1 away. Okay. Now I have my one triangle directly on top of the other triangle. So yes. So yes, they are similar. By a dilation of 1/2 and a reflection across, right, we flipped it across the y-axis. Okay. All right, let's look at our next example. Again, same thing here. I'm going to start with ABC. I don't know why I'm writing it like that. That's not going to be helpful for us. And A is at -5, 0. B is at -5, 5. And C is at 5, 0. So again, the first thing I'm going to do is find my scale factor. So this is my pre-image. I'm going to call this my image then. So K equals I over P, which is 1, 2, 3, 4, 5, 6. 6 over, and it looks like that's going to match this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 3/5. So I'm going to multiply each of these by 3/5. Again, feel free to use a calculator for sake of time. I'm just going to write out what it is. So A prime, -5 times 3/5 is -3. 0 times 3/5 is 0. B prime, -5 times 3/5 is -3. 5 times 3/5 is 3. C prime, 5 times 3/5 is 3. 0 times 3/5 is 0. So I'm going to graph those new ones. -3, 0. -3, 3. And then 3, 0. Okay, then the next thing I'm going to do is this kind of looks like a rotation to me, 180 degrees. When you're rotating 180 degrees, you just make your x and your y negative. Or change the sign. This one, double prime, is negative, so it's going to become positive. 0, it doesn't matter. So it's going to become 3, 0. -3, 3. It's going to become 3, and negative 3. I'm just changing the sign. Negative 3 becomes 3, 3 becomes negative 3. C prime, 3 becomes negative 3, 0. So let's see what that did. So I have 3, 0, that goes to here. 3, negative 3, so 3, negative 3, goes to there. And then negative 3, 0 goes here. And so that was our rotation. Instead of a rotation, some of you might see a reflection. A rotation of 180 degrees is the same as reflecting something twice. It doesn't matter. This rotation just saved me an extra step. I would have to do it 2 things instead of just 1. Okay. Now, these look pretty much the same. All that seems left is I have to just move it so that it matches those points. So I'm going to try and figure out what that translation is and then algebraically show it. So I'm just going to look at this point and this point look like they're going to match up. It's moving 2 down and 1 left. Or 1 left and then 2 down. So to get to my next point, a triple prime through 3 here, I'm going 1 left in the negative direction. And then I'm going 2 down, so that's also negative. B triple prime, 3 minus 1, negative 3 minus 2. And C triple prime is negative 3 minus 1, 0 minus 2. Okay, so be very careful with which one's your x's and which one's your y's. Okay. So 3 minus 1 is 2, 0 minus 2 is negative 2. 3 minus 1 is 2, negative 3 minus 2 is negative 5. Negative 3 minus 1 is negative 4, 0 minus 2 is negative 2. Let's graph those and make sure they're in the same spot. Net 2, negative 2, that matches. 2, negative 5, that matches. Negative 4, negative 2, that matches. Line them all up. Okay? So are these similar? Yes. Then I'm just listing what I did. Dilation of 3/5, a 180 degree rotation, and translation left 1 and down 2. Okay? So at the end, just make sure you list everything that you did. All right, last example. Looking at this one, I'll start with A, B, C and try and go to D, E, F. The first thing I'm going to try and do, they look to be about the same size, so I'm just going to try a translation first. So this is nice, they gave the points to us. A is at negative 6, 5. B is at negative 2, 10. And C actually has a typo. If you notice in the graph, this is not negative 3, 3. This is negative 3, 2. Right? Over 3 up 2. So I'm going to change that here so that we don't get confused. So it looks like it's just a translation. They look to be the same size. So I'm just going to try and figure out how far it's moved. These upper points seem the easiest to me. 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7, 8 down. Okay. So I'm going to show mathematically what these new points would be. Negative 6, oops, it's right, so it's positive, and of course it moved. So negative 6 plus 7, and then it's down, so it's negative. So 5 minus 8. -6 plus 7 is 1. 5 minus 8 is -3. So that works, right? 1, -3, it's right there. Same thing for B is going to be -2 plus 7, comma, 10 minus 8. -2 plus 7 is 5. 10 minus 8 is 2. That looks good. -3 plus 7. 2 minus 8. -3 plus 7 is 4. And 2 minus 8 is -6. Oh no, right? 4 and -6. That's in the wrong spot. It's supposed to be a 4 and -5. You can look at this and say, I could rotate this triangle. I could reflect this triangle. I could make it bigger or smaller. But since 2 of the points match up and the third don't, there's really nothing you can do. These aren't the same shape. Okay? They're slightly different triangles. So, no, not similar. That is it for 1A.3. We will work on our activity tomorrow. I will see you guys then. Come in with any questions.